Okay, this is the video for the tutorial. The first question tells you that there is a manufacturer. They claim that the mean driving per mile for sedans is less than the competition. And you're given two different ends. When you're given two different ends, that would be an example for a two sample independent. Two sample independent. Again, because you have two different ends. These are the formulas you need for a two sample independent. They're either in the Brightspace now or they will post them soon, but this is what you need to have for a two independent samples. Here you have two groups, the manufacturer, that would be group 1, and the competition. They give you the average for this one, it's 0.45. I'm only doing this version, so your numbers might be a little bit different. And the average here is 0.47. Standard deviation here is 0.05. Here is 0.07. Sample 1 is 32. Sample 2 is 33. So now we know it's an independent system, and remember, the claim for the manufacturer that it's actually less. So first, they want you to state the null hypothesis, H0, and the alternative. Now for a two-sample independent, the null hypothesis is always mu1 minus mu2 equals 0. And the alternative is whatever we're trying to prove. We're trying to prove less, so we say mu1 minus mu2 less than 0. And if you guys remember from previous videos, less, that's an indication of one tail. When you're testing less, it would be one tail. When you're testing more, it would be one tail. When it's not equal, that's the only time it's two tail. So after stating the hypothesis, they ask you, what's the pooled standard deviation? So standard deviation, or S of pool. In the formula sheet, you will see a formula for SP. So I'm gonna tell you what the formula is. So SP is the square root. Standard deviation 1 squared n1 minus 1 plus standard deviation 2 squared n2 minus 1 all over n1 plus n2 minus 2. I'm gonna raise some of these numbers, so be able to do the standard deviation pool. According to the question, the first standard deviation is 0.05. You square it, and it's a sample of 32 minus 1. The other one is 0.7, and the sample is 33 minus 1. And n1 plus n2 minus 2, that would be 32, 33 minus 2. So I'm gonna take my calculator here. So it's the square root of 0.5 squared times 32 minus 1, 0.7 squared, and all of this over 32, 33 minus 2. The answer is 0.61. That's your SP. After finding the standard deviation, they want the observed test statistic. T observed or T statistics this is the formula for t-statistic, t-stat or observed. So t-statistic is this formula. So you need average group 1. That's the average for the manufacturer. That's 4.5. Average group 2. That would be the 4.7. Then you have mu1 minus mu2. That's 0. Square root. You need standard deviation pool, which is the one we did. You square it over the first sample, and you square it again over the second sample. So I'll grab my calculator, do this. Squared over 32. And then squared over 33. This gives you a t-stat of -13215. After this, they ask for the degrees of freedom. I also told you here what the degrees of freedom is for this case. So I'm gonna erase some of this. So degrees of freedom is sample 1 plus sample 2 minus 2, 32 plus 33 minus 2 as 63. And then they want the p-value. I also said in previous videos how to find the p-value for t. You need your DTT. You need degrees of freedom, 63. You need the value of the test, -13215. And you need to know whether you're one-tail or two-tail. We say here we're one-tail. So you go to your t-table. Now in the t-table, you go to the degree freedom 63. There is no 63, so I'm gonna use the closest but less. I'm gonna use 60. That's the closest to 63 but less. And then I'm gonna look for this number. Forget about the negative. You're looking for 1.32 in line 60. It's in line 60, it's between the first two numbers. It's between 129 and 16. You put your two fingers on these two numbers, you go up to the one-tail, you see that it's somewhere between 5 and 10%. So your p-value is somewhere between 5 and 10%. Again, to do this, you go to the degree freedom. There is no 60. There is no 63, so we look for the closest. So the closest would be 60. You go to the degree 60, you look for this number. Doesn't matter if it's positive or negative, so you look for the value. And you see it between the first two numbers. You put your fingers on these two numbers, you go up to the one-tail percentage, and it's somewhere between 5 and 10%. Now, unfortunately, when you do this tutorial, they want to look for the exact number. So you either do this in Excel, you can do it in Minitab or whatever, but in the exam, when you do it in the exam, it's enough to do this. Just say it's between this and this. You don't need to find the exact. Now, to do the exact, I recommend to do it online. You go to, just go to Google and say T calculator. And one of the links you'll see is for a website called StarTech. Oh, so Star Trek, sorry, the show. So when you go there, you'll see they will ask you for the degree freedom. So when they ask for the degree freedom, you just say what the degree freedom is. And actually you can use the 63 here. and they ask you for what the t-score is. You put the number, so you go, it's minus 1.3215, and then say calculate. You don't worry about the probability. You only need the you only need the degree of freedom and the t-score, and they tell you that your p-value is 0.956. So the exact p-value 0.956. And as you see, this is the exact. We know it's between 5 and 10%. That's good. Now going back to kappa. Now the last question. So after finding your p-value, you need to know if you're supporting the claim. Remember, the claim is the fact that's being less. So the claim is HA. Now I'll write again. I did this earlier. General rule: if you prove that p-value less than or equal alpha, you're going to reject H0, conclude HA. And if your p-value is more than alpha, you're not going to reject H0. You're not going to conclude HA. Now let's see. P-value is 5%. Your p-value is 9%, 9.5 almost, and your alpha is 5. Is p-value more than 5 or less than 5? Definitely more. So in this case, we do not reject, we don't conclude the HA, so the answer no. We are not supporting the claim. This is the first question for the tutorial. Now I'm going to go to question 2. So if you go to question 2 and read it, it talks about a shoe company, and they claim that when athletes use this, they increase their vertical jump. And they give you the results before trying the shoe and after trying the shoe for 8 different athletes. So when you see the before after, that's a 2-sample dependent, also called paired. And also for a 2-sample dependent, there are a set of formulas. So in the question, they tell you you have the athletes 1, 2, all the way to 8. You have the numbers for before. You have the numbers for the after, and there is a line called difference, and that's the important line. We'll talk about it, why it's the important line for a dependent. Now, the claim, remember, the claim that it has increased the vertical jump. Now, what's the null hypothesis and the alternative? Well, since it's a dependent system, we use mu d. This is 0, always equal. And since we're testing for increase, we say more than 0. And again, anytime you're testing more or less, or that would be 1 tail. The only time it's 2 tail when it's not equal. And remember, this here is the claim. The claim is that it has increased. So after doing the null hypothesis and the alternative, they ask you which of the following is an appropriate test. It's a paired test. What's your observed statistics? This is your T observed or T stat. And if you look at this formula, they want D bar. And what is D bar? D bar is the mean of difference. That's why you need this line. If you go up to the question, you'll see there is a mean and standard deviation. You need the mean for the D difference, that's your D bar. And the standard deviation for the difference, that's the standard deviation for difference, that's your SD. And both of them, D bar, SD, part of the formula. So according to this question, my D bar is 1875, mu D is 0, SD according to this question is 2.1002, and it's the square root of sample 8. I'll do this in the calculator quickly. And the number here is 2.53, or to be exact, it's 2.5251. Then they ask you for degrees of freedom. I put it here. Degree freedom, remember when we did it as a dependent, independent, you add them -2. Here, it's one sample, so you take it -1. So your degrees of freedom would be 7 here. Now then you find the p-value. To do the p-value, as we said, you need the DTT, degrees of freedom, test, tail. Degree freedom 7, test is about 253, and it's one tail. We said that earlier, it's one tail. You go to your t-table. You go down to the degree freedom 8. You'll see that it's between 139. Your number is 253, so it's between 2.3, 2.8, 2.3, 2.9. In fact, with the degree freedom, you go up to the one tail. You're somewhere between 1% and 2.5%. But again, they want the exact number, so go to that website that I told you, get the exact number, but it should be very close to 2%. So, last question, is it more than alpha, less than alpha? Are you rejecting, not rejecting? Do we support the claim here? Well, alpha is 5%. 2% is less than alpha, since alpha is 5%. Anytime you less than alpha, we said it, you reject H0, you conclude HA. So you're concluding HA, so yes, we are supporting the claim. So this is the answer for the tutorial number 9.